Okay, we're going to have a look at volumes of revolutions. So we've done lengths of curves, we've done surface areas of solids, and now we're going to actually look at the volume of a solid. So you've done this previously in Maths 1, and these formulas should look vaguely familiar. And this is called the method of thin disks. And the way this works is that if you've got a function like so y equals some function of x, and we're trying to revolve it around, say, the y-axis, so we're going to use this formula here, then what it does is it looks at dy being a very thin piece of y, and it takes this disk, which when you rotate it will end up being a disk like so, which effectively has radius equal to x. So the volume of this little disk is the surface area of the circle that it's part of, which will be pi r squared, which is x squared, and the thickness is dy. And then you say the region I'm interested in is between y1 and y2, so you integrate from y1 to y2 and you get that full volume. So this is the formula for the integration by thin disks. The problem with this is that it always has to come back to the axis. Okay, so your radius is a disk, solid disk, it doesn't have a hole in the middle, so you can only work out volumes that touch the axis. So if you want to do something like the outside bit here, you have to do some fancy subtractions, which you're probably familiar with from Maths 1. So I'll just recap that with an example down the bottom here, and then we'll have a look at a different way of doing it, which gets around that problem.